Dear, dear third year students, today let us discuss about complex integration and the related theorems. As you know, we had already discussed some important and key theorems on complex integration. There are Cauchy's integral formula, Cauchy's integral formula for finding the first derivative, second derivative, etc. Lewis theorem, etc., etc. So, based on that theorems, based on those theorems, we are to discuss something, or we are to solve some integral, complex integral here. Today, let us solve a typical problem on complex integration and related theorems. Let us solve a problem. Show that integral along C e to the power 3z divided by z minus pi I dz is equal to minus twice pi I if C is inside the circle mod z minus 1 is equal to 4, and this is equal to 0 if C is the ellipse mod z minus 2 mod z plus 2 is equal to 6. So we are to evaluate this complex integral. Here the function is, here the complex function is fz is equal to e to the power 3z, which is an exponential function, exponential complex function. It has two value. One is minus twice pi I. If C, here the integral is closed, it is a bounded integral. Integral along the closed curve C. So it has a value which is minus twice pi I if C is inside the circle mod z minus 1 is equal to 4. This is a circle, and this integral also has another value which is 0 if C is the ellipse, which is represented by this equation mod z minus 2 plus mod z plus 2 is equal to 6. So আমরা এই দুইটা এখন করব। Solution. Fz, here the complex function is e to the power 3z, is analytic inside and on the circle mod z minus 4 is equal to, mod z minus 1 is equal to 4. Also, z minus pi I, here z minus pi I, that means z is equal to pi I is a point that lies inside the closed curve So also z is equal to a is equal to pi I. Is also a point inside the circle C. So now mod z is equal to mod pi I is equal to pi. As we know, the modulus of I is what? The modulus of I is 1. So the modulus of z is pi here. We know the value of pi, which is 3.14 and less than 4. The equation of the circle is mod z minus 1 is equal to 4. This represents a circle having radius 4. So since the point z is equal to pi, we find here mod z is equal to pi, which is 3.14 and is less than 4. Then the point z is equal to pi I lies inside the said circle, which is represented by the equation mod z minus 1 is equal to 4. Therefore, we can write z is equal to pi I lies inside the given circle. So we have already justified the question, the given question, that the point z is equal to pi lie inside the circle. So now we need to find out this value. So now by Cauchy's integral formula, now by Cauchy's integral formula, we have integral along C e to the power 3z divided by z minus pi I, which is given in the question, is equal to twice pi I f pi I. Since z is equal to pi I is the point that lies inside the circle C. So now we can write twice pi I f pi I should be equal to e to the power 3 pi I. By Euler's formula, this can be written twice pi I cos 3 pi I, sorry, cos 3 pi plus I sine 3 pi. This can be written. So from this, let me erase this part. From the bottom, let me write down here integral along C to the power 3z z minus pi I dz is equal to twice pi I cos 3 pi gives value 0 minus 1 and this gives value 0. That means minus twice pi I. Therefore, integral along C e to the power 3z z minus pi I dz is equal to minus twice pi I, which is shown here. So this is the first part. of the problem. This is the solution for the first part of the given problem here. Now let us show integral along c e to the power 3z divided by z minus pi dz is equal to 0. The condition here is if c is the ellipse. Here in this case c is the ellipse, and the equation of the ellipse are given by mod z minus 2 plus mod z plus 2 is equal to 6. Okay, let us solve this. Second part, here the given function is fz is equal to e to the power 3z divided by z minus pi a, which is given mod z minus 2 plus mod z plus 2 is equal to 6 is the equation of an ellipse whose foci means focuses. Let me draw the sketch of the given ellipse here. So this equation represents an ellipse, and the illustration of that ellipse is this one. So it has two foci. We know ellipse has two focus. Here one is 2O and another is and another one is minus 2O. Okay, this is the center and the coordinate of the center is 0 0. Okay, now see mod z minus 2 plus mod z plus 2 is an equation of an ellipse whose foci are one is minus 2 0 and 2 0. Okay, and the length of the major axis is what? 6. According to this figure, we can easily figure this out. The length of the major axis is 3 plus 3 is equal to 6. And the focus point or foci are 2O and minus 2O of the given ellipse. The point z is equal to pi I lie outside the ellipse. This is easily understandable because the length of the major axis is 6. This portion represents the half of the length of the major axis, which is 3. Our given point is z is equal to pi I. So 3.1416 something. So this is easily understandable that the point z is equal to pi I must lie outside the ellipse. So now by Cauchy's integral formula, we can write now by Cauchy's integral formula. We had already gone through the Cauchy's integral formula. The Cauchy's integral formula for first derivative, second derivative, Leibniz theorem, and some other important theorems on complex integration had already been discussed before you online. So now by Cauchy's integral formula, we can write, since the given point lies outside the circle or outside the curve, here the curve is an ellipse. So if any point lies outside the circle or outside the given curve, then according to Cauchy's integral formula, we can write integral along C fz dz is equal to 0. We have learned this from Cauchy's integral formula. So we can write down integral along C fz. Here fz is e to the power 3z divided by z minus pi I dz is equal to 0. So which is shown here. We are to prove that the integral along C e to the power 3z divided by z minus pi I dz is equal to minus twice pi I when C is inside the circle mod z minus 1 is equal to 4, and integral along C to the power 3z divided by z minus pi I dz is equal to 0 when C is the ellipse. We found by calculating, by our computation, we found the point z is equal to pi I lies outside the ellipse, which is why the value of this integral is 0. We found the value of this integral inside this circle, and the value is minus twice pi I, which is already been shown. So these are all about the complex integrations formula. Today we used Cauchy's integral formula for solving this problem. Next days or in the next class, we are to discuss more problem. We have to solve more problems on complex integration soon. So hopefully you have gone through all this. So till then, stay safe and good. Thank you.